All right, so we're going to do the second day for 4.3. We're going to spend all day talking about one topic here, and that topic is the idea of a reference triangle and what that means and how to use a reference triangle. But before we begin onto that part, I want to make sure we all have one thing down exactly perfect no matter what the case, okay? And that thing is how to draw a certain type of triangle. So I'm going to move over here for just a second. All right, this is practice before we begin. All right, if I gave you, remember this from geometry, a 30, 60, 90 right triangle, the only thing that's going to matter in this section is the relationship amongst the sides of a 30, 60, 90 and a 45, 45, 90. All right, do you remember how they go from geometry? Yeah, how do we label all these sides from geometry? What's across from the 60-degree angle?
X root 3.
X root 3, very good. X root 3. What's across from the 30-degree angle? X, and what's across from 2x? Good. Okay, you've got to have this part memorized. All right, that's going to save you so much time and grief if you just remember that the size of the triangle doesn't matter. The only thing that matters is the relationship among the sides. This is all from geometry, okay? There's another one. What was the other one that we did? 45, 45, 90, right? 45, 45, 90, okay. So if this is 45 degrees, then that one up there is also 45 degrees. And what's the relationship among the sides of a right triangle? That's 45, 45, 90. X, X, and then X root 2. Absolutely, okay? If you can keep these in mind, okay? And remember, it doesn't matter the size of the triangle. The only thing that matters is the relationship among the sides, because the angle ratios will always be the same. Okay? So if we keep those in the back of our mind the entire lesson, we're going to be off to a really good start. So let's go back over here, and let's begin here. So I want to find the 6 trig functions of the sine, or I'm sorry, did I say? No, of just 315 degrees. Of 315 degrees. Okay? So here's how I like to teach this. I first like to actually draw the angle of 315 degrees in standard position. So what quadrant will I end up in?
So
James cracks me up, dude. Okay, what quadrant will I end up in? I will end up in the 4th quadrant, absolutely. So here's X, here is Y. I'm going to use blue. So remember, drawing an angle in standard position, here's my initial side. If it's 315 degrees, that means I'm going to swing clockwise or counterclockwise, everybody? Counterclockwise all the way down and end up in quadrant number...
Because it's positive, right?
Yeah, because it's positive, exactly. So here we go. I have some angle now. So this is my angle, which I'm going to call theta, and that's equal to 315 degrees. You guys okay with that part? Okay, awesome. Now, if that big angle right there is 315 degrees, then there must be a little leftover angle that's in quadrant 4. Do you see the little leftover angle?
Yeah.
Yeah.
45.
45, but where is it?
Over that.
Over there, right? Yeah, exactly. What does that mean? Okay, so this angle right here, this leftover angle right here, has to be an angle of 45 degrees. Why is that true?
Because you 360.
Yeah, there's 360 all the way around, right? So if there's 360 all the way around, and I've already used up 315, well, then I only have 45 left. Okay, so what we're doing here is we're learning how to use what's known as reference angles, okay? This right here is what's known as a reference angle, okay? And you can draw a reference angle in all 4 quadrants. The thing to keep in mind with a reference angle, there's 2 things to keep in mind if we all agree to these 2 things. One, it is always acute. What does that mean?
Less than 90.
Less than 90. It's always acute. It's also positive. Always positive. Okay, I have a 45-degree reference angle. It's acute. The other thing that's really important is that it is always between the terminal side, that says terminal side, by the way, the terminal side and the x-axis. Okay, it's always between the terminal side and the x-axis. What do I mean by the terminal side?
The The ending side.
Yeah, the ending side. This is my terminal ray. This was my initial ray. Remember, I don't have to write the I and the T to remind us of initial and terminal. I have the arrow to indicate which one is the initial and the terminal. Remember, the initial side is always glued down to the positive x-axis anyways, right? So it's always between the terminal side and the x-axis. Why is that important?
It can't be like within the angle itself.
It can't be, well, it could if it's in the quadrant 1, but the reason is that I don't want to draw, by accident, I don't want to draw this angle. See it? That's the angle between the terminal side and the y-axis, which is also included in that 315, right? Okay, so I don't want to draw that one. Now, once I have my reference angle, I can then draw a reference triangle. All right? So we always drop an altitude from, I'll use a different color here, I'll use red, from the terminal side back to the x-axis perpendicular. So you always draw the triangle, the reference triangle, with the reference angle included. Okay? So now, look what I have. I have a 45, 45, 90 right triangle. You guys agree with that part? Okay? Now, consider any point that's on this particular terminal ray of your angle. I'll call that point P. Okay? I'll consider that point P. Can I label the sides of my triangle now? Do I know the relationship among all the sides of my right triangle? I do, right? This side is x, this side is x, then this side has to be what? X root 2. Everybody agree with that part? Okay, so those are the sides of my triangle, okay? Now consider the point that's located in quadrant number 4. How could I label that point?
X.
There you go, you got it. X comma negative x. Why is it negative?
Because you go down.
Because it's a point that lives in quadrant 4, and it is okay to have negatives associated with a point in quadrant 4, obviously. All of the x coordinates, the y coordinates will be negative. Now, check it out. I have everything I need, don't I? I have the x value, just happens to be x. The y value happens to be negative x. What about the r value? You got it.
Yeah.
That's x rad 2. So look, I have everything that I need. I have everything I need. So look, I can now talk about after all, I want the sine of 315 degrees.
Oh, now you can use that.
Now we can use what we have, right? What is the sine defined to be? It's defined as the y value over the r value. Well, in that case, the y value happens to be what? Negative x. The r value happens to be what? X rad 2. That simplifies to negative 1 over root 2. Notice the x's cancel out because, again, it doesn't matter the size of the triangle. All that matters is the relationship between the sides. Got it? Okay, if I keep going with this, I'd get negative root 2 over 2. And yes, we would keep going with it. Okay?
Yeah.
Let's make some sense of this. Think about this. If I 315 degrees, it puts me in quadrant 4. Remember the little acronym that we have figured out to remember, right? We have all students take calculus, right? So does it make sense for us that our sine is negative because we're in quadrant 4? Yeah. So our cosine should be what?
Positive.
Yeah, it should be positive. So let's go ahead and see. I want the cosine of 315 degrees. That's defined as the x value over the r value. Well, the x value is just simply x. The r value is x radical 2. Look at that. That's 1 over radical 2. That is a positive root 2 over 2. Okay? Let's do the tangent. The tangent of 315 degrees, it's the same definition, y divided by x. Well, in this case, it's going to be negative x over x, which just gives me a value of negative 1. Awesome. Perfect. Okay. Please take out your calculators. Okay. I'm going to put my calculator in degree mode since we're dealing with the degrees. So I'm going to go to my mode button, and I'm going to put it into degree mode. So boom, boom, go over, hit degree. Okay, second quit. Awesome, clear this out. All right. Now, the calculator, I'm gonna verify the work that I've done on the calculator. But you have to know what the calculator is doing. It's not enough to just punch numbers in and get the answer out. You have to be able to draw the picture and think your way through all the problems. So if I want the sine of 315, I would punch in sine 315. And when I push enter, I should expect a negative value. And I do get a negative value. I get negative 0.707. What does that mean? What does that mean? It's the decimal form of what? Of negative root 2. Exactly. All divided by 2. And then there you go. There it is. The exact same answer, okay? Punch in for me cosine of 315. We would expect to see the positive of the same answer that we just got. Yep. And then punch in the tangent of 315. And of course, we get the negative 1. All right? So we can kind of verify what we're doing as we do it. And I hope you now understand why some values are negative and some values are positive. It's all based on the angle that we're in. Okay, let's do another example. We're going to find the following without a calculator. So not going to use a calculator. We're going to think our way through all these problems together, okay? Here's the first one that I'm going to give you. I'm looking for the sine of negative 210 degrees. The sine of negative 210 degrees. Okay. So no calculator. First thing we're going to do is we're going to actually draw this angle. So let's draw an angle that's negative 210 degrees. What quadrant do I end up in?
Third.
No, not the third.
Just kidding. Oh.
The second. Why do I end up in the second quadrant?
Negative.
Because it's a negative, right? So here we go. Remember, standard position. My initial side is glued down to my positive x-axis. My terminal side is somewhere over here in quadrant number 2. This right here is an angle of negative 210 degrees. So I want you to draw it first, okay? Now that we've drawn it, can you identify the reference angle? It's not 90 degrees, no. It's not 270, no. Oh, remember, the reference angle has to always be acute and always positive.
Oh,
It's up
I thought
three.
where it was going.
No,
30 degrees.
it's 30 degrees.
Oh.
It's 30 degrees, okay? I see your hand in just 1 second. Yeah, the reference angle is right here, you guys. And this is an angle of 30 degrees. How do I know that's 30 degrees?
210.
Exactly, because if I go halfway around the circle, I've gone 180, and I've gone 210, which is exactly 30 past 180. Oh, so you guys see that? That's very important because now I can draw my reference triangle. See that?
Oh.
Ah, okay, I can draw my reference triangle. Now I have a 30, 60, 90. Put all the relationships that you know about a 30, 60, 90 on the triangle right now, okay? So this one's 30, this one's 60, so this has to be x rad 3. This has to be 2, no, this has to be 1x, and then this part has to be 2x, okay? Okay, now that we have the sides labeled, I want you to consider a point. So consider a point right there. We'll call that point P. What would be the coordinates of that particular point if I had to get there in the coordinate plane? Negative x root 3, comma,
2x.
comma x. Good. All right. So the x value is negative x root 3. The y value is an x. What's the r value?
2x.
2x. Very good. So now the sine is considered as the y value over the r value. The y value in this case is what? X. The r value is what? 2x. If I divide those, what do I get? So you mean to tell me that the sine of negative 210 is positive 1/2. That's what we got. Okay? Let's check and see. All students take calculus, right? S is the sine function. So it's in quadrant 2, and I can verify that I did this correct by taking the sine of negative 210 degrees, and of course I would get positive 1/2, okay? But I want you to be able to do the analysis by drawing this picture and figuring it out, and all we have to really know is the 30, 60, 90 relationship of a triangle, and then consider a point on that ray. Okay, tangent of 5 pi over 3. If we're in radians, then I want to stay in radians, all right? If we're in degrees, we can stay in degrees. I want us to actually get practice of staying in the actual measure that we're working with. Okay, 5 pi over 3. Where is 5 pi over 3? What quadrant? It's in the fourth quadrant, absolutely, right? Okay, so I'm going to draw an angle in standard position. Here we go. My initial side is glued down to the positive x-axis. And I got a 5 pi over 3 angle, looks something like this. So here is an angle of theta that's equal to 5 pi divided by 3. Okay? Now remember, this is 2 pi all the way around, right? Well, 2 pi is the same thing as 6 pi over 3, right? They can be represented the same way. So what is my reference angle?
30.
Yeah, this angle has to be pi divided by 3, which of course is a 60-degree angle. Okay. Now, I can draw my reference triangle. So I have a 30, 60, 90. So that means that across from 60, this is x radical 3, this is regular x, and then this is 2x. Okay? So there's all the information I know about a 30, 60, 90. Now, let's consider a point. Let's consider a point on that terminal side. How could I navigate to that location in the coordinate plane? I would go over x, and I would go down what? Negative x root 3. Which one am I interested in? I'm interested in the tangent. The tangent is defined as the y value divided by the x value. The y value is negative x root 3. The x value is just x. Simplifying that, I get negative square root of 3. That makes sense because let's think about it. All students take calculus. The only one that's positive should be cosine. So I'm getting a value of negative radical 3. And my calculator will help me verify that. But I should be in what mode, you guys? Radian, because I'm taking a radian. Awesome. You guys are totally on board with this. I love it. So here's a radian. Second quit. So I want to do the tangent of 5 and then pi's divided by a 3. And notice I get a negative something. That's the same thing as negative square root of 3. And you can see there that we've done it correctly. Okay, here we go. Example C. Here we go. The secant of...
So bad.
Okay, secant, negative 3 pi over 4. Here we go. Let's draw, how do we draw negative 3 pi over 4?
What is that?
What is that? That's a great question. It's an angle. How do we draw an angle? Yeah, it's exactly. So remember, pi over 4s are really easy to draw.
45, right?
So negative 1 pi over 4, negative 2 pi over 4, negative 3 pi over 4. Remember, pi over 4 angles are really easy to draw because they're all 45s. Okay, so I just go 3 45-degree angles in the clockwise direction, right? Yeah, super easy, right?
45.
So right here, this is an angle of negative 3 pi over 4. So far, so good? Okay. What is my reference angle?
A little one.
A little one right here. And how much is that worth?
45.
That's also worth 1 pi over 4. Now I can draw a reference triangle. Awesome. Okay. So look, this is going to be x, this is going to be an x, this is going to be an x root 2. Okay. Now, consider a point on the terminal side of my picture. I'll put my point right here. I'll call that point P. What would it take to get to that point? Negative x, right? So far, so good? Okay, good, because I'm in quadrant number 3. And remember, this is the x value, this is the y value. All right, awesome. The secant of negative 3 pi over 4 is defined as secant is r over x. Thank you. R divided by x. The r value is x radical 2. I got it from right there. The x value is negative x. Therefore, the secant should be negative root 2. So the secant of negative 3 pi over 4 should be negative root 2. You guys cool with that part? Okay, now how do we punch in a secant in the calculator just to be sure that we're all on the same page? Ah, very good. What mode should I be in? Radian. So I'm going to do this. In the parentheses, 1 divided by the cosine of negative 3 quantity pi over 4, double, enter. I get this. Is that the same thing as negative square root 2? It sure is. And push enter, and we get that as well. Okay, when you try all 3 of these, I want you to only use your calculator to check the answer when you're done. draw a picture to represent the angle, and remember that some angles are undefined, and that's okay.
Number 4.
All right, this is what we figured out. This answer is a value of 1, this is an answer of 0, this is a value of undefined.
Is this 0? Why is 10?
Because
Okay.
Draw
Can we
here
just
y
go
and
to the
x,
next
and
one?
y has to be 0. What's x?
why is the 2?
What's
Same stuff, different representation, okay? Here we go. If you know that the sine of theta is 3/7, and you know that tangent is negative, what is the cosine of theta? Now this seems really challenging, but all you have to do is figure out what quadrant you're in from this information here. Okay? So the sine is positive and the tangent is negative. What quadrant do you have to be in? If sine is positive and tangent is negative, you have to be in quadrant 2.
So cosine is positive.
Okay, you have to be in quadrant 2. So now, if I draw a triangle in quadrant 2, okay, here's a triangle that's in quadrant 2, and I know that the sine is equal to 3/7, then I know,
opposite.
there you go, this has to be 3, and this has to be 7, because it's defined as the y value over the r value.
So 7 squared.
okay.
So therefore, the part that you would have to figure out using the Pythagorean theorem would be this side, which would be the square root of 40, because we've already done it before. Okay. Now, if I consider a point though over here, if I consider a point, what would it take to get to that point? I'd have to go negative root 40 and then up 3. And I'm interested in the cosine of theta. Therefore, the cosine of theta is the x value to the r value, which is the x value of negative root 40 to the r value of 7, and that is my answer.